In this question, we're asked to find the slant asymptote of f of x. But before we do that, let's actually just look at this function and decide whether or not we should be looking for a slant asymptote or maybe it's a horizontal asymptote. If you remember, the way we know that this is going to have a slant asymptote is because the degree of the numerator is higher than the degree of the denominator, right? If you took the limit to infinity, then we've been saying that this approaches, well, we've been saying it does not exist, right? Or approaches infinity. But it turns out it actually approaches some line, right? So maybe it does something like this and then approaches that line all the way up, right? Okay, so that's the scenario when we have a higher degree numerator than denominator. Okay, so how do we do this? Well, we're going to divide these polynomials. We're actually going to divide and see what we get out of it. Now, one thing that you may be tempted to do is you might think, well, I'm good at this. I can do synthetic division that I learned in 30-1. Now, the reason why you can't is because the ones in 30-1, I'm just going to give you an example. That might have been something like, I'll even show the numerator. Maybe it was something like this. 2x cubed minus 3x squared, plus x minus 3. And in those cases, that was something like x plus 2, right? And then if you remember with synthetic division, we'd use like negative 2. So we're actually not going to be able to do that, though, because it's because of this x squared term that we have going on, right? You would if this had been x plus 1, okay? But in this case, we're going to have to use long division. All right, so let's set this up. So I'm going to write the numerator again there. So 2x cubed minus 3x squared plus x minus 3. And we're going to divide by x squared plus 1. All right. So now what I suggest doing, though, is rewriting this with an x term as well. So what I mean by that is it's like this. So it'd be x squared. And then I'm just going to write this as plus 0x, because there is no x term, plus 1. And it's just going to be nicer for me just to line things up. Okay, so when we do this, what we're doing is we're going to say, okay, how many times does this go into this? But for the most part, we only have to look at our first term, and we can kind of ignore these like smaller terms in the back for now, right? Just for the first part. So we'll say, how many times does x squared go into 2x cubed? Okay, and if you're having trouble figuring that out, really what that's saying is x squared times what is 2x cubed. So you can really divide those, right? You say, okay, well, if I had 2x cubed divided by x squared, well, x squareds would cancel, and you'd end up with just 2x. So x squared goes in 2x times. And do you see how I wrote it over the x term? That's just kind of a nice way to keep everything neat. All right, so from here, what we're going to do is we're going to go 2x, and then we're going to have to multiply by every one of these terms. So let's do that now. So we'll go 2x times x squared, and this is a good sign. You'll know you're doing things right when we do this, right? 2x cubed. I wanted that to be the case, right? Because I'm going to subtract this in a minute, and that'll cancel out. All right, so then 2x, and now what we do is we're going to multiply by our x term as well, but that's really just 0. So let's do this. Let's say plus 0x squared. Doesn't really matter that it's x squared does it. It's just so I can keep those guys lined up is the only reason I did that. And then the last one, 2x times 1 would be 2x. All right, so now what are we going to do with that? Well, think about this part as being in brackets, right? That's what we found out. And now we're going to subtract this. Okay, so 2x cubed minus 2x cubed is 0. Or just leave it blank if you like. Negative 3x squared minus, this is just 0, so still just negative 3x squared. And then now we have x minus 2x. So this becomes negative x. Now it's at this point that we're going to bring down the negative 3. So negative 3. And now it's like we're starting over. Now we're going to say, okay, how many times does this go into this? And again, I really just have to look at our first term for the first part of this. So how many times does x squared go into negative 3x squared? That's going to go in negative 3 times. All right, so then from there, we're going to go negative 3, but then we have to multiply by all of these. Okay, so negative 3 times x squared is negative 3x squared. And then negative 3 times 0 is 0x. And then negative 3 times 1 is negative 3. Okay, so then from here, we are going to subtract these. So we've got negative 3x squared minus negative 3x squared. That's like adding, so that becomes 0, which is perfect. Now, on here, we've got negative x minus 0, so this is still negative x. And then the last part, we have negative 3 minus negative 3, so like negative 3 plus 3, which is 0. So I don't really need those zeros. So in the end, we have a remainder of negative x. All right, so our slant asymptote isn't the remainder, though. Our slant asymptote is actually our line, right, in the form mx plus b. So this is really going to be our slant asymptote. Okay. That being said, well, I just want to show you one more thing here. You may remember from Math 30-1 that we can write our answer. If we actually divide these, we can write this as the quotient plus the remainder over the divisor. Maybe you remember that form, right? So what that means is if like I can say my original function here, right, just dividing those two, would be the same thing as, well, the quotient. So this would be the same thing as 2x minus 3 plus, and then our remainder in this case was negative x over, and then our divisor, which was x squared plus 1. Okay, why I bring that up is because imagine taking the limit to infinity of this. Limit as x approaches infinity. Okay, well, it's going to be approaching a very, very large number. And imagine what happens to this as you become very, very large, right? You've got some very, very large squared number in the denominator and some very, very large number in the numerator. This is going to be approaching 0. So as we get further and further out, the closer and closer this chunk gets to 0, our function is going to really just be mimicking the line 2x minus 3. And all of this just becomes like unnecessary, like because our graph just pretty much becomes 2x minus 3. To demonstrate this idea, what I've done is graphed our function here. And then you can see, you know, that we have it's approaching infinity, right? And now I'm actually going to turn on that slant asymptote, so 2x minus 3 that we just found, right? So you can see that our graph is going to be approaching that line. And the further out I get, the more that line pretty much just is that 2x minus 3. The graphs become identical, even at like 100, right? But especially if I start getting out closer to like, you know, 1,000 or 1,000,000 or 1 billion, they almost become indistinguishable.